All right, these are 5C notes. So let's start us off by looking at, again, the definition of a polynomial function. Recall, in order to be a polynomial function, the exponents are all whole numbers and the coefficients are all real numbers. Today we're going to be adding, subtracting, multiplying, and not dividing yet, but adding, subtracting, and multiplying polynomials. We're going to also factor the sum and difference of cubes. We're going to learn a new pattern. All right, this is function notation, so if I want to find f of x plus g of x, I'm just going to take my two polynomials and add them together. So basically I'm combining like terms. All right, make sure that when they're in standard form. That means that the highest exponent is first and it counts down. So that my f of x has a degree of 3. All right, so here it's just combining like terms. So you can a couple of different ways. You got to keep yourself organized, because unfortunately there's lots of little terms here now that we can make, careless little mistakes. So when I add g of x, I'm just going to line it up underneath its like term. Remember that it has a coefficient of 1, 5x squared. There's no x term, and then we have plus 3. So we're just going to combine like terms. You can do this horizontally or vertically like I'm doing here. So this is going to be 4x cubed minus 7x squared plus 4x minus 3. Just be careful with your signs. All right, now this is not an equation, this is an expression, so we're not doing anything with this. We're just combining them whatever way they tell us to combine them, and that's our final answer. Don't pull out a GCF or anything like that, okay, because it's not an equation. All right, be careful with the second one, because we're subtracting g of x. So f of x, and when I set this up, I'm going to do this horizontally. All right, we're going to subtract that entire g of x. So please take the time and do this step, because I don't want you to make a mistake. Because what you have to do with that second expression is distribute that negative. Okay, so take the time and write this out. Don't do too much in your head, because like I said, it's lots of terms, really easy to make, silly mistakes, unfortunately, with this math now. All right, if you need to, you can stack them, or we're combining like terms. So we got 3x cubed minus 1x cubed, so that's 2x cubed. X squared, so we're going to have 3x squared plus 4x minus 9. So there's my new expression. All right, adding and subtracting. Just like I said, just be careful with the subtracting to make sure you distribute that negative. All right, let's move on to multiplication. So let's multiply these two functions. Not functions, let's multiply these two polynomial functions. Okay, so we're going to multiply the two together. So we got h of x, which is 3x squared minus x plus 4. And we're going to multiply by x plus 2. I like to think of this as superfoiling. We're going to multiply everything in h of x times everything in j of x. Okay, so that means we're going to multiply 3x squared times 3x. So we're going to get 3x to the third. And then 3x squared times 2, we're going to get plus 6x squared. All right, now we're going to do the same thing with our negative x. We're going to multiply negative x times negative x. And here again, you can stack these. So negative x times x is negative x squared. I can put it underneath my x squared term. Then I'm going to have negative x times 2, which is negative 2x. And then finally, let me change my color so you can see what I'm doing. I'm going to multiply by 4. So you can see how, like I said, these things can get messy. So you got to keep yourself nice and organized. So 4 times x is 4x. I'm going to stack it underneath my like term. And then we have 4 times 2, which is plus 8. And then to get our final answer, we're just going to combine like terms. So this is one way to organize it. Like I said, you can do it horizontally. Just make sure you have, here's definitely where you don't want to scrunch up your work. Give yourself plenty of room so you can read what you wrote. All right, so that's our new polynomial function, f of x times g of x. All right, so let's look at some new notation here. Here, these are called compositions. So this is asking us to find j of 2. That's telling us that x is equal to 2. So what we're going to do, now keep that h around because we're going to come back and deal with that h later. Every time we have an x, and we're looking at j of x, we're going to plug in a 2. So that's going to give us h of 4. So what this is saying is now my x is turned into 4, and I'm going to take that 4 and I'm going to plug it everywhere I have an x in h of x. So it's going to be 3 times 4 squared minus 4 plus 4. Notice I'm putting parentheses. When I substitute in, I'm putting parentheses inside. So in a composition, you're putting one function inside of another one, sort of like my nesting dolls over there in the corner. All right, let's do the arithmetic. So this is 16 minus 0. 3 times 16 is 48. So h of j of 2 is equal to 48. You always work from the middle out. Okay, the insidemost parenthesis out. All right, let's look at the difference of the second one. All right, what's happening here? We're keeping it in terms of x. Let me give ourselves some more room here. Get rid of all our little cute little doll. All right, this time we're taking j of x, this entire function, and we're plugging it into h of x. So that means I'm going to plug it in everywhere I have an x. I'm going to substitute in x plus 2. So what do I get? I get 3 times x plus 2 squared minus x plus 2 plus 4. And we're going to have to simplify this. You notice here again I'm putting parentheses around whatever I'm substituting in. Alright, so this is going to have to get multiplied out, expanded. Alright, don't multiply by 3 yet. So I got x squared plus 4x plus 4. Distribute my negative plus 4 that was already there. Alright, let's distribute the 3. And then we're going to combine like terms. So you see how we get, like I said, lots of little parts to these questions. So unfortunately, you got to be really careful so you don't make careless mistakes. All right, we want our final answer in standard form. So start with the highest exponent, combine like terms. All right, this gives me 2, right? Negative 2 plus 4 is 2, plus 12 is 14. So here's my final answer. Notice how we're still coming back to Algebra 1, combining the like terms from Algebra 1. All right, so what we've done, we've added, we've subtracted, we've multiplied polynomials, and we've used composition, put one inside of the another. And notice here, if this is a number, then your answer is going to be a final number. If this is a variable, then your final answer is going to have variables in it. Okay, let's move on. Let's look at a cube. Remember, we've been dealing with cubes now. All right, we got special patterns for cubing a binomial. So a plus b cubed means this. You're going to multiply a plus b times itself 3 times. All right, it's never, ever going to equal a to the third plus b to the third. Never. Always. Bad, bad, bad math. Okay? Now, you could expand this by distributing. That's always fine. But there does exist this pattern. And if you take a moment, it's really not that hard to learn this pattern. I'm going to show you with the example. Here's what's happening. The only thing I have to remember is those middle two terms, there's going to be a 3 there. All right, look at what's happening to my a's. My a exponents are counting down. So a to the third, a squared, a, and then a to the 0, which is just 1. And my b's are going to count up. So 0, 1, 2, 3 exponents. So this is what we're going to do with it. Here's our example over here. So in my example, a is 3x and b is 1. All right, so we're going to start off with the a term. We're going to cube it plus 3. Can't forget that 3, which is my favorite mistake to do, is forget that 3. All right, we're going to square a, and now my b is going to come into the first power. Plus 3 is locked in there. We're going to count down with my a, so it's to the first power, and we're going to count up. So now we're at the second power with my b, and then finally my b is going to be cubed. And I'm not going to have any a. All right, now we just got to clean this up. So 3x to the third is 27x to the third. 3x squared is 9x times 3 is 27x. All right, 1 squared is 1 times 9x, so that's 9x, and then 1 cubed is 1. So there it is expanded out using my pattern. Now when you minus, notice that my signs are changing. I don't worry about that because if I use the method I did in the first one, my signs are going to fix themselves. I don't have to worry about my signs. So let's look at this one. A is 2r, but B you have to treat as -3 for this pattern to work. Okay, same thing. We're going to cube the A plus 3 square the A, bring in the B, which is -3 to the first power, plus 3. All right, A's to the first power. B is now going to get squared. And then finally, we're going to cube the B. All right, now we get to clean it up. So this is going to be 8r cubed plus, all right, be careful here. You've got 4r squared. Okay, so this is going to be 4r squared. This is going to be 4 times 3. That's 12r squared times -3. So this is going to give me a -36r squared. All right, what are we going to get for this one? This becomes 9, right? -3 squared is 9 times 6r, which is plus 54r. And then -3 cubed is -27. So here again, see how we get the signs? We get the minus, the plus, the minus, without having to memorize that. All right, so that's the pattern for cubing a binomial. All right, you can learn this pattern, or like I said, you can multiply them out each time. All right, so, all right, what's next? All right, let's look at this one. Let's multiply this binomial times this trinomial and see what we get. All right, so we're going to distribute here again. So we're going to multiply 2p times 4p squared, and we're going to get 8p to the third. I'm just distributing, so I'm going to get 12p squared. And then I'm going to get plus 18p. All right, do the same thing with the -3. So I'm going to get -12p squared minus 18p, and then finally minus 27. Okay, let's combine like terms. What are we left with? 8p cubed minus 27. So our middle terms dropped out. This is going to help us factor. We're going to go backwards because if you notice these are both perfect cubes. Okay? Because the cube root of 8p to the third is 2p, and the cube root of -27 is -3. So that's going to help us set us up to factor the sum and difference of cubes. We factor the sum and difference of binomials, okay, of perfect squares, dots. Now we're going to do the sum and difference of cubes. So it's going to help us with the following pattern. Now, unfortunately, you're going to have to memorize this pattern to be able to factor the sum and difference of cubes. All right, so like I said, we're going to use the abbreviation SUMSAP to help us remember the pattern. So anytime you factor the sum and difference of cubes, you're going to get a binomial times a trinomial, because that's what's going to make those middle terms drop out. All right, here's how I like to do this. So A is the cube root of x to the third, which is x. And B is the cube root of positive 125, which is 5. All right, so we're looking at this first pattern up here. So it's a binomial, so you just put these together, x plus 5. All right, here's where my SUMSAP comes in, my trinomial. You square A, that's S for square, opposite multiply. So this is 5x, the opposite of 5x is -5x. That's my OM, opposite multiply. And then square, again, square my B, and that's always going to be positive. So positive 5 squared is plus 25. All right, so that's how you factor that sum of the cubes. And this only works if they're both perfect cubes. Now this won't factor. All right, that won't factor. But it's all about memorizing this pattern. And this is probably one of the hardest things to stay in your heads for some reason. That's why I came up with the sum SAP. All right, let's look at some more examples. All right, this is a difference of cubes. So A is the cube root of 8, which is 2, and B is the cube root of negative y to the third, which is negative y. All right, let's use our pattern, our binomial. You just put them together, 2 minus y. Our trinomial, you square it, so 2 squared is 4, multiply, opposite multiply, so that becomes plus 2y, and then you square negative y, which is y squared. And leave them in this order, okay? If the problem starts out with the coefficient, the constant first, leave the constant first in your answer. Otherwise, you're going to have to factor in a negative. So, like I said, leave it alone. Okay, let's try another one. All right, look at this one. 64 and 27. Well, they're both perfect cubes, too. All right, you can still have a GCF here. We'll look at those in class. But A is the cube root of 64n to the third, which is 4n. And B is the cube root of negative 27m to the third, which is negative 3m. All right, pattern. Put them together for your binomial. Square the first, which is 16n squared. Multiply and take the opposite, so it was minus becomes plus 12mn. And then square the last one. It's always positive, 9m squared. Okay? All right, one more. If you want to try it on your own before me, then pause the video for a moment. All right, so let's see what we got. A is going to be the cube root of 27g to the third, which is 3g. B is the cube root of 343, which is 7. All right, put them together for the binomial. All right, the trinomial. Sum SAP. So we're going to square it, opposite multiply, and we're going to square it, and remember that it's always positive. So that's going to be plus 49. So that's how my sum SAP works. Okay, see if you have any questions, and we'll talk about it in class.